Great. Thanks, Matt. Really psyched to be back here tonight. So I'm going to talk to you about the 3 things you need to know before crowdfunding. But before I dive into that, just a quick little bit about my background. I had the chance to work for iRobot for 10 years and build the first 4 million Roombas. We used to build about 40,000 a week. Started Dragon about 5 years ago to help, hopefully a lot of folks like you in the room today, go from a working prototype, make manufacturing feel easy, pick a factory, and scale up. I'm also a partner with Chris over at Bolt, which is an early stage VC fund with the best machine shop in Boston. So before I roll further into this, let me just take a quick survey. How many folks have built a hardware prototype before? Okay. Has anybody sold more than 5,000 units? Awesome. 50,000? Cool. Awesome. And last question. How many people have done a crowdfunding campaign? Cool. Thanks. OK, so as you probably may have guessed, manufacturing is complex. And hardware is just fundamentally different than software. You know, why is it complex? Well, what we see in working with our customers is that it's really a long journey with many unknown unknowns. And I say that because you don't even know what's going to get you until it's already got you, and at that stage it's too late. What are some of those things? Well, a few are things that drive cost. So COGS, or cost of goods sold. You know, how do you actually figure out how much your part costs, which is critical to the health of your business. Next one is tooling. You know, for this, it's mostly an injection molded part. How much do those tools cost? Important to know. And then other manufacturing costs. Lead times. So in the volumes that we deal with, which are usually 5, 50, 100,000 million units, you can't just buy something on DigiKey and expect it to arrive overnight on your doorstep. But you're buying, large numbers of, or large quantities of components that may have a lead time of up to 12 weeks. And that's just before the thing arrives at the factory. If your schedule is predicated on shipping product by Christmas and you don't plan that in, and it's an exponential sales cycle, that's going to be a problem. So it's really important to understand that. Quality. In hardware, quality is permanent. You can't just go and push a new firmware update. But when you build and ship a product, it has to work when it gets there. And we sort of think about quality roughly in 3 main buckets. And you can think of it like an AQL level. Critical, major, and minor. Critical is if something goes wrong, it kills somebody. Major is it doesn't work. Minor is it has a scratch. Anything you build that plugs into the wall has the ability to burn somebody's house down. If you build 1 million units, statistically, a very small number of those can fail and cause a big problem. So you have to be really confident you've got this stuff right. It just takes longer to iterate. So again, there's not an instant compile. It's getting better with 3D printing and amazing fabrication techniques like that. But if you think of injection molding tools, those are typically 6 to 8 weeks just to cut the tool. So it is a longer cycle time. You need this thing called design for manufacture and assembly. So again, just picking on injection molding, there's certain design rules from uniform wall thickness to draft around and so on that you've got to create a design in such a way that you can actually go ahead and mold it. And if you don't do that, it's going to be incredibly expensive and time consuming to build your product. And it's also probably not going to be a very high quality. So that's just one more layer. How do you pick a great factory and then how do you manage them? How do you scale a team? How do you keep track of the schedule and project management? And then all of the specialized skills you need from hardware, from mechanical, electrical, software, supply chain, costing, sourcing, quality manufacturing. So there's a lot of different moving parts in this. It also requires cash, and that's why we're going to talk about crowdfunding. Typically what we see is you come up with a great idea, maybe you still have a job, you start bootstrapping it out of your own money. Hopefully you never mortgage your house, because that's generally a really bad idea, but it's something entrepreneurs are prone to do. Then you'll talk to some friends and family. Hopefully they'll throw in a little bit of money and help you build the prototypes. Maybe you'll get some angel investors. At that stage, if it's a consumer electronic product, and that's really what we focus on, crowdfunding can be a great tool. After that, you've proven the traction in the market, and it's a great way to attract VC funding. In fact, sometimes it's a requirement. And then you'll have sales. Now, that's kind of the timeline. Where I want to focus is how to avoid getting yourself in a hole with crowdfunding. And again, crowdfunding, we like to joke, is like a power tool. It gives you great capability, but if you use it incorrectly, you'll cut your leg off. So we want to help you avoid doing that. And the real challenge is, in the old days, what we would do is we would build something and then we would sell it. But we had the confidence that we could actually build the thing. Today, you can sell it before you build it. And the concern is that if you've got a great industrial design, which we'd call looks like model, you make a compelling video, and you describe it to the world and get people to pick it up and buy it before it exists, it's actually possible to really paint yourself in a corner and not raise enough money to fulfill on your promise to deliver, or really to sell something you can't possibly build. By the time you find it out, though, it's too late because you've got all these commitments of people really wanting their thing, and they can get ugly. So the 3 things I'm going to talk about with you today from a manufacturing standpoint, I'd encourage you to think about before running crowdfunding. And the 3 things are, how much money do I need to raise? How long is it going to take before I deliver my product? And with the prototype I built now, how far away am I from a design that I can actually deliver? So we'll do these one by one. How much cash do you need? So what drives the cash? Some piece of it is the non-recurring engineering to get your prototype built. A lot of great teams will do this in-house. Sometimes you'll want to bring in outside people that may have expertise in a field that's not in-house. That all takes money. And that's to get to a point that it's designed for manufacture and assembly. The cost of goods sold. So it's absolutely critical that you understand what your product costs. Your margins are what's going to fuel your profit, your advertising, and basically your success. If you sell a product for $100 and it costs you $150, that's incredibly bad. And you should know ahead of time before you set the price. So we'll help you figure that out. How much do the tools cost? And what are the manufacturing costs associated with that? And that could be as simple as driving from here to your factory upstate, or it might be something more complex and building in Mexico, building in China. And then not to forget the crowdfunding transaction cost. So the platform is always going to take a cut. And if you're a Coolest or a Pebble, that can be a significant amount of money that you want to factor that in ahead of time. So we don't have much time today, so I'm going to drill into cost of goods sold. So again, that's critical to the health of your company. You'll start with what we call the bill of materials, which is basically the raw ingredients that are going to go into building your product. And what you want to do when you approach this, and again, just think a big Excel file, is break everything down into, and I'll just pick on this remote, is to the mechanical parts. So I'd separate my injection molded parts, then my purchase parts like the screws and the springs, then my electronic components, then typically the packaging, the deco, and so on, so that you break them all out. You want to make sure you include labor because you've got to pay the workers to put it together. And that really depends on where you're building. In the US, we see sort of 20 to 30 bucks. In China, I'm seeing anywhere from $2 to $7 on average. So you can imagine if it takes an hour to build your product, that's another 20 bucks that you've got to add. And the cost of goods sold has a pretty significant effect on the retail price. So it all does matter. You also want to include scrap because not 100% of the products you start with are going to end up going through the line. The overhead, so the factory has to pay for electricity and all that good stuff. The profit, the factory has to make money. And then for each item, and again, I'll just pick on the plastic here, you want to break it down into a mathematically driven formula. So if I take the top clamshell housing here, it doesn't do me much good to know that it costs 28 cents because I don't know if I'm getting a fair price or not. What I'd want to do is break it down and say it's 14 grams of Chimay ABS 747. I'll allow 10% scrap. The sprue and the runner weigh 10%. It's one up, one cavity. And from there, I can calculate the actual price of the resin going into this. The second half of the equation is the molding. So what tonnage press is it running on? What's the overhead of the press? And what's the cycle time? And if I do that precisely, then I just have a mathematically driven formula. And I have confidence that I'm paying a fair price. I've also created a tool where if I change from ABS to polycarbonate, I can instantly calculate what the price difference is. So there's no mystery meat in there. You'll want to do that for everything. And again, it's well beyond the scope of what we have time for today, but just to start thinking about that. That was how much it will cost. How long will it take? So this is typically, when people come to Dragon, this is typically what we see. We have the idea, and I'm just going to use the analogy of the alphabet, where A is the idea and Z is the product delivered to the factory. Prototyping is the majority of the work. You do some crowdfunding, you manufacture it, and then you deliver it. That's often what we see. In reality, when we look at it, the idea is super important, but that's just the beginning. You'll spend a little time prototyping. You'll get ready for crowdfunding, which is what I'm talking about now. That's a super important step. We don't want to just jump into it or throw it on the wall and see if it sticks. You'll crowdfund. The manufacturing is the majority of it, and I'll talk a little bit more detail about the steps in there. And then you'll deliver it, and that takes time. Let's say, for example, you build it in China. If you're going to put it on the water, that's typically 5 weeks from when it leaves the NTN until it arrives in the port of Los Angeles. That's a considerable amount of time you want to factor in. If you're building it upstate, it might only be a day, but it's important to plan that into your crowdfunding campaign. And just to emphasize how this stuff is hard, I thought it would be interesting to have an illustrated video. So this is me with a camera a bunch of years ago in one of the Roomba factories. And this is just one of 4 wings building the product. We had about 5,000 workers doing the 40,000 units a week. So if you think of the amount, or how do you go from an idea and a prototype in 7 people's heads and get it into 5,000 people that probably don't speak English, are in a different part of the world, and are turning over 20% year on year, you get a little bit of a view of how the stuff becomes pretty challenging pretty quickly. So for the schedule, again, as I talked about, Christmas has a fixed date. Most consumer electronics are driven by the holiday season. If you miss that, you'll lose a tremendous amount of revenue. So you really, really, really cannot be late. One of the first products we built was this sort of smart baby doll for Hasbro, and we ended up building about 100,000 of them. But we didn't get it done in time. We should have been shipping in September. We didn't ship till in November. And as a result, we only sold 100,000, which is not even really getting to first base. It could have been the next Furby, but because we were late, it didn't make it. It didn't get on kids' Christmas list, and nobody probably has ever heard of it. And that's just because we were late, because we didn't know what we were doing. You've got to plan a contingency in your schedule. Nothing ever goes right, and it always takes longer than you think. It's really important, no matter where you build in the world, to have feet on the ground so you can close the loop locally. You can look and see if something is drifting and take action. If you think of the alternative, it's you build a product, it gets put in this 5-week boat, slow boat from China, it gets delivered, it is used for a few days, and then it breaks and the customer calls up. And the problem is, if you're building 40,000 units a week, 10 weeks have gone by, you've built a lot of units that are all going to come back and you're going to be out of business. So there's nothing like your own eyes and ears on the factory. Sort of common sense, track it in very small milestones. If something drifts, take immediate action. Hope isn't a strategy that it's going to get better. Do it right the first time. And this is sort of a detailed schedule that we use for the Roomba. But sort of the way I would think about it is, after you've got a working prototype, it's typically 6 to 8 weeks to pick a factory, and about 9 months from when you pick a factory until the first product rolls off the line. And then from there, it depends on how you ship it. If you air ship it, it's 2 weeks. If you sea ship it, it's about 6 weeks before it gets to the customer. And then the last question is, how far am I away from a design that I actually can start manufacturing? And these are the different stages. So we'll start with a paper sketch, where you're just sort of playing with the idea. Then you'll make a prototype. So this is a duct tape, bubble gum, and so on. Probably a 3D printed model, which we call looks like. So a little bit further along, and that's certainly a new technology that's really enabled the hardware revolution over the last couple of years. Then you'll go for a pretty industrial design model. You'll have the model with all the drafts rounds, uniform wall thickness, ribs, and so on, so it's ready to hand over. You'll actually then have injection molded parts, or die cast, or stamped, or machined. And then you'll have a final product in manufacturing. So those are just a laundry list of sort of the different steps along the path. And those are the key things. I'd love to answer any questions that you have.
It's perfect timing actually to the second. Questions? All right. Otherwise, I have some. So what are some of the mistakes that you see people do?
Use the chairs. Yeah, so being an entrepreneur means you're optimistic, which is incredibly useful. And I know when I used to teach at Olin, one of the things I loved about my students is they didn't know how hard something would be. And they'd actually just do it and they'd pull it off. And I saw that at iRobot. Like, we had no idea how hard it was to build a 5-degree of freedom consumer electronic robot back then. Like, anybody with common sense would say, don't do that, you're totally going to fail. But nobody told us, and we pulled it off. Sometimes, though, it can backfire. I mean, there's hard repercussions to hardware if you get it wrong. So optimism is good, but temper it with a little realism. And it always comes down in our world to cost, quality, and schedule. So if you're managing those 3 things, you're going to be OK.
So what do you think is going to happen to the crowdfunding space then? So like, 2 years from now, you said that it made it a little too easy to sell something that you couldn't build. So what's going to happen in 2 years?
Yeah, it's something we think deeply about. I mean, on one hand, it's just such an amazing enabling tool for hardware that it lets you validate a product, get cash up front, and really build an engaged community around what you're doing. But on the other side, if you think of it like from an Amazon analogy, suppose you went to Amazon and ordered 4 things and only got 1 of them, you'd probably stop doing that. You wouldn't engage in that behavior. So it's something we're super worried about. And we, to address it, we created a product called the Dragon Certified, which answers these 3 questions. But regardless of what people use, what we care more than anything is people think deeply about crowdfunding and line it up right ahead of time, as opposed to winging it. Because I think if people wing it, at least for hardware, it's probably going to be behavior that people don't participate in.
What are some of the products that you're particularly excited about, either through Dragon or others, in terms of what's coming out with just personal?
Yeah, oh, there's so much cool stuff. Like, obviously, what Jake and the crew are working on. I'm a backer and really excited about that. I'm really into drones. I think that's an underserved area that's starting to take off a little bit. I mean, it's such a green field for things you can do. I think the kitchen space is starting to heat up, so to speak.
So the drones are taking off and the...
Exactly. But yeah, I mean, it's such a great time to be...
The driverless cars are just getting rolling?
Yes. But it's an awesome time to be in hardware. And I think we're just at the dawn of the hardware revolution. There's so many more things to come. As components get cheaper, more and more people get into it. There's better tools. And hopefully, we can help manufacturing feel easy and help navigate those waters.
Very cool. If there are no questions, actually, I'm holding the mic.
Key from ICE. I have a question. How do you see the production from China moving to the U.S. Or staying in China? There have been some problems lately with the cost of labor, and it doesn't seem to be as competitive as it used to be.
Yes.
Do you see China staying in the situation where it is? I know for very large quantities, probably the supply chain is still strong in China, but there are also some other markets, like some other places like Malaysia or Korea, which may be interesting as well.
Yeah, that's a great question. So in China, the labor rate goes up roughly 20% year on year. And right now, it's a small percentage of the bill of materials, but obviously that's exponential increase. What we're seeing is more and more automation in China, just because the factories are super concerned about that, and they're also incredibly mechanically inclined, that they have the ability to build very practical automation. But if you look at China, originally it was just a low-cost labor base. But now the domain knowledge is insane. The supply chain is incredibly well managed and localized. Like if you look at the Pearl River Delta, there's anything you could possibly want to build in toy, consumer electronic, medical is right there. That I think there's less of a short-term risk of it going away. I mean, we worry about currency exchange, if there's any epidemic or the governments don't get along, all of those things. I guess the way we would slice it and why we get super excited about the US is really looking at it from a volume standpoint. So if you're building less than 5 or 10,000 units, China doesn't make sense unless you live in China. We say they are domestic manufacturing, and since we're in the US, that would make a lot more sense in that, one, no Chinese factory is really going to be interested in those low volumes. And two, when you're doing that, you're probably bringing a new product to life, and you're going to want to talk to the person manufacturing and say, oh, no, that hole doesn't really go there. Even though I did that, it goes over here, and let's do this, and let's build 10, 100, and so on. So I think that's going to start taking off, especially those are the crowdfunding volumes where there's a lot of push behind it.
One quick one from Jake.
When does hardware get easier for an entrepreneur? Like, and what does easier look like? I mean, we're like at the top of the stack in crowdfunding and prototyping and 3D printing, and it's really easy to do a rendering, and then at some point you just fall off a cliff, and you need somebody with 20 years of experience who's like done it before to sort of guide you through that. What does Heroku look like? I'm sure you get this question all the time, but like, will that ever come? And if so, when?
Yes, so yeah, manufacturing is insanely complex, but, and it's a great question. Our mission at Dragon is to make it feel easy. So kind of looking at the different processes through a timeline. Step one is getting ready for crowdfunding, you crowdfund. Step two is how do you pick a factory? And that's a tricky process in that if you get it right, you can build anything and you're in great shape. If you get it wrong, it's going to be incredibly difficult to succeed. So we see ways that can be made much more simple by automation. And then once that's tackled, then actually getting into the project management. So how do you, and the whole trick with anything is just breaking it into discrete steps. So how do you create a manufacturing service agreement, which is a contract with the factory, a comprehensive quality plan, design for manufacturing and assembly, costing and sourcing, and project management. And if you break those down, there's all discrete steps that can be automated, sort of taking the intelligence in our collective heads and getting that wisdom in the form of process and tools online. So it will get there.
So a couple of years.
Yeah, I would expect, well, let's say, the getting ready for crowdfunding, I'd expect this year, the RFQ middle of next year, and then the project management has a little bit of a longer tail because it's sort of human augmented software. So maybe 3 or 4 years. And again, being an entrepreneur, I'm optimistic.
All right, that's all the time we have. Thank you so much.
Thank you.